Welcome to AI Podcast. I'm Daniel, and with me is Maya. Today we're unpacking a paper called Direct Preference Optimization, or DPO. Here's the quick headline. DPO is a simpler way to align language models to human preferences. Instead of training a separate reward model and running a full reinforcement learning loop, it turns preference learning into a single, stable objective that behaves like classification over preferred versus non-preferred responses. In tests on sentiment control, summarization, and single-turn dialogue, it generally matches or beats common PPO-based RLHF setups, while being easier to implement and more stable.
Hi, Daniel. Glad to be here. Before we dive in, who led the work?
The lead author is Rafailov, with colleagues at Stanford. Senior authors include Chelsea Finn and Christopher Manning. The paper was presented as an oral at NeurIPS 2023.
Nice. So what problem are they addressing in plain terms?
Large language models learn from huge text corpus form, but that doesn't guarantee they act the way users prefer. The standard recipe is RLHF. First, supervise fine-tuning on demonstrations. Second, train a reward model from human-labeled preference pairs. Third, use reinforcement learning, usually PPO, to optimize the model under a constraint that keeps it close to a reference model. It works, but it's complex, compute-heavy, and sometimes unstable. DPO asks whether we can keep the alignment goal while avoiding the heavy RL machinery.
All right, what's the core idea behind DPO? Give me the intuition, not the equations.
Think of a supervised baseline as your reference. For each prompt, you have two candidate responses, one humans prefer and one they don't. DPO compares how much your current model favors each response relative to that reference. Then it nudges the model to increase the relative likelihood of the preferred response and decrease the other. The update is larger when the model currently disagrees with human preference. No separate reward model, no PPO loop, just a single classification style loss on preference pairs.
That sounds refreshingly straightforward. How did they test that it actually works?
They ran three scenarios. First, controlled sentiment on IMDb, a clean setting where a sentiment classifier gives a clear notion of reward. Second, summarization on the Reddit TLDR dataset, where they look at preference, win rates, and robustness to decoding temperature. Third, single-turn dialogue using the anthropic, helpful, and harmless data. Baselines include standard supervised fine-tuning, a variant that trains only on preferred responses, and unlikelihood, objective, and PPO.
And what did they find, without drowning us in numbers?
On the sentiment task, DPO traces a better reward versus drift trade-off than PPO and the other baselines, meaning it gets more improvement for the same distance from the reference model. On summarization, it typically matches or edges out PPO and stays robust as you change sampling temperature at inference time, where PPO can be more brittle. They also test out of distribution by applying the Reddit-trained models to news articles, and DPO holds up better there. In single-turn dialogue, DPO improves over the dataset's chosen responses and over the simpler fine-tuning baselines. For evaluation, they use GPT-4 as an automated judge and validate with a human study to check agreement, which looks reasonable.
Okay, promising. But let's be careful. What are the caveats?
First, evaluator reliance. Automated judges are convenient, and the authors do validate with human raters, but broader human evaluation across tasks would strengthen the case. Second, baselines. Reproducing strong PPO runs is tricky. The paper discusses this, but there's always some implementation variance. Third, in scope. The results use small to mid-size open models and single-turn tasks, so questions remain about scaling to very large models, multi-turn conversations, and tool use. Fourth, assumptions. DPO leans on standard preference models and a KL-style constraint, which are reasonable but still simplifying assumptions. And importantly, you still need preference data, which isn't free.
Makes sense. Can you paint a concrete picture of one DPO training step, no math?
You take a prompt with two responses, N and B. Humans say A is better. The reference model and your current model each assign probabilities to A and B. If your model already prefers A, strongly relative to the reference, you make a small update. If it still leans toward B, you make a bigger update that raises A and lowers B in a balanced way. Repeat this over many pairs, and the model internalizes those preferences while staying anchored to the reference.
Got it. If I'm a practitioner maintaining an alignment pipeline, what's the practical takeaway?
DPO is a strong first choice when you have preference data. It's simpler to implement than RLHF with PPO, generally stable and competitive in quality. If you need very specific control that DPO doesn't give you, you can still fall back to a full RL setup, but many teams can start with DPO and iterate faster.
And where should research push next?
Scaling studies on larger models and multi-turn interactions, more diverse human evaluations alongside automated judges, robustness to noisy or mixed human and AI preferences, applications beyond text like images or code traces, and better data efficiency through semi-supervised approaches without drifting into reward hacking.
That's a clear roadmap. Want to wrap with one line for the big picture?
Sure, DPO reframes preference alignment as a clean, classification-style update that avoids a separate reward model and the RL loop, yet still delivers stable training and competitive results.
Thanks, Daniel. This was AI Podcast. If you found the discussion useful, share it with a colleague, and we'll see you next time.